We have been looking at the upstream oil industry. We said that there are three oil industries that make up this sector, where we have the upstream, the midstream, and downstream. And basically, we are saying the upstream involves exploration and the production of oil and gas. Basically, we say this is the part of the oil industry that includes exploration of gas and oil and the production to extract it from the earth. When we talk about discovering, then bringing it to the surface, that is what we call production or extracting it from the surface. Now, when you look at production and exploration, it involves a number of processes, and we're saying, first of all, we have to search for underground oil. Then after searching, after a thorough search, and we establish that the oil is there, then we go on to drill the wells, and actually, after drilling to operating the wells, we extract the crude oil or natural gas and we bring it to the surface. The process of drilling is what we said that we use quite a number of equipment, and then I talked about the oil rig that I've shared in our first bit. And we say the upstream is therefore having exploration or search to discover that oil and gas really exist in the underground strata. Then this is followed by a production where we have drilling of the oil well and then recovering the oil and gas, which is going to be now taken for purification. Basically, there are quite a number of activities in exploration. That's what I said. I said we call search, and the first one is what we call under exploration or the search methods. We have geological studies. Some of you, when I talk about geological studies, you may ask yourself, what does this mean? We say that geological studies, this involves, actually, when you talk about geology or what geologists do, geology involves a specific field where we look at the origin, distribution, and then production of oil or natural gas. And geologists, what geologists do is to analyze source rocks that are rich in organic matter, in Jersey, or rocks that could be potential sources of oil and natural gas. So in our geological studies, first of all, we need to discover, do these rocks have oil or natural gas in them? Then we analyze the geological structures or stratification or stratigraphic layers that will permit accumulation of petroleum to form the subsurface. Actually, we look at what we call traps and seals. We shall look at these traps and seals as we go on. But we say we analyze, geologists analyze geological structures and then also make a thorough analysis of what we call a stratigraphic layer. And when you look at these stratigraphic layers, these layers permit the accumulation of natural gas and oil. I shared a structure in our first presentation part I shared a structure of this, which I was trying to, when we're talking, okay. When you look at the screen, this is what we look at. This is a trap, an anti-clean trap. I've been talking about traps and seals, which we use to analyze whether there is oil. And that is a trap. You see, a trap will show that the oil is there. And when we analyze it very well, we can tell that there is oil. So this is the work of geologists. And this is what we carry out in the geological studies. We identify areas with the favorable geological conditions. That geological conditions are indicative of oil and gas existence in the substrata. And then we try to look at their characteristics. Now, when you look at these rocks, you have to look at their characteristics, as you see, and this will determine the operation of drilling in itself. So, in geology, we study, geology involves the direct study of the earth, and this is done through direct observation on the rock from the point of exposure, or we drill a bit to determine the structure. When you look at this trap, when you drill, you can tell that we have a cap rock. Then if we look at the seal and we find that there is a free gas cap, then automatically we know in our anticline petroleum trap, this one is supposed to cover the oil, and then we design the particular equipment after getting the measurements, and then with the rig, the length of the rig that will be used to get the oil. And when you look at this diagram, you find that the rig is dipping down into the oil itself. Actually, we have that one that will go down the dry hole into the water, the salt water layer. Then we have the other drills that tap into the free gas cap, and then others which will tap directly into the oil. Now, these ones are done under the geological studies, and the geological studies will tell that there is oil, and then how it is going to take us to drill it from the surface. And also, this one will also be accompanied with the histological or historical evolution or analysis observations of the rock itself. Now, that is the first thing we look at under the geological studies. When we move on to our presentation, we find that geologists will take some time. Those of you are having the oil and gas book. This is well explained on page 3 when we talk about the deep explanation of the geological studies. And after looking at the nature of the rock, we go on to prepare for the next stage, which is drilling. Now, under petroleum exploration, apart from using geological studies, we may also use what we call contour maps. Contour maps. We say contour maps are so effective, or are one of the most effective means of displaying information about the geological structure. You see on the screen, we have the contour maps. These ones directly bring out the faulting layers. Actually, they give us the structure of they give us the appearance of the rock, where we expect to find the oil and the gas in the layers. So by doing it, so they even indicate the degree of faulting. The degree of faulting will have a direct impact on the machinery or the direct equipment type and the strength that it should be used to drill the oil from the surface, from the underground strata. They even indicate the degree of buckling. So when you talk about buckling and the faulting layers, being displayed by the contour maps. This means that information about the geological structures of a given area where oil is suspected to be present is clearly going to be brought out. And when we look at our screen, which we find that these are the contour maps. I said that this is well explained on page. Now the contour maps are well explained on page 4. Some of you are having the books. When you go to the page 4, you find that this is well explained. Those of you who have not yet got the books, please try to look for the books and get them, and we follow closely. Now, we have what we call surface maps. Now, surface maps, in some areas, the presence of subsurface geological structures are clearly brought out by what we call surface maps. So we say, especially the untidiness is evident at the surface. When you look at the surface maps, that is an indication that it could be oil at that point. In such cases, geologists can search for anticlines, and anticlines, when we are looking for anticlines, we involve direct studying of the topographic maps or air photographs. Now, we have what we call the anticlines here. When you look at this is a typical anticline formation. And I've said, when you talk about surface maps, anticlines clearly show where the oil is. When you look at the oil, the water layer, the oil is above the water, and then there is a free phase of gas. All these are clearly brought about by anticline formation maps. And we've said that surface maps, we find that geologists search for anticlines by studying topographic maps or surface maps and air photographs, and by doing into the field and studying the rock layers, they expose places where we find oil. And in this case, it is very important, or it is very easy for us to know that oil is there. So we say topographic maps are the ones on which the shape of the land surface is shown by contour lines, and the relative spacing of the lines indicate the relative slope of the surface. So that is a simple definition of what we call surface maps. Surface maps sometimes are also known as topographic maps. We say these are the ones on which the shape of the land is shown. The shape of the land surface is shown by contour lines, and the relative spacing of the lines is an indication of the relative of the slope surface. So those are surface maps. We continue and we talk about we've been still looking at surface maps, and we've talked about the surface maps. These are really used to also used in oil exploration process. Now, we have what we call geophysical surveys, and we say geophysics uses the methods of classical physics to obtain a geographical image of the subsurface. We are looking at what is there in the rock. Kubanga oil ava wansi eyo, buli kye tutunuulira twaba twagala kumanya waakula watya eyo, waliyo oil. Tosobola genda n'okola biggest investment nga tonnaba kumanya ddala oba gyebiri, because the first stage is the explore. After exploring, then you go on production. That's why we say exploration and production. And in production, we have drilling. Before you put in the heavy equipment to drill, you have to be sure that there is what we can drill. And that's why we say there is geophysics, and actually we use geophysics involves use of classical physics to obtain the geophysical image of the subsurface. Tulina okumanya wansi wakula watya wafaanana watya. And that's why for every standard physical property, there is a corresponding geophysical technique. Now, there are many techniques, geophysics techniques, and actually, one of them is using density. We can also talk about magnetic susceptibility method. We can also talk about electrical conductivity method. We can also talk about velocity and density. All those are geophysical methods. Then we have the gravity method. Then we have the magnetic method. And then we can also have the resistivity method. And also we talk about what we call seismic method. Now, when we talk about geophysics, all these methods, all these techniques, geophysical techniques, are important in explaining the geophysical image. I call upon your research on these areas. You go and read about these techniques, geophysical techniques, which are used to come up with a structure. I said they have the density, that is one, then magnetic susceptibility, then electrical conductivity, velocity and density method. Then we also have the gravity method, magnetic method. We shall try to talk about magnetic method as we go on. And now we use magnetometer. For gravity, we use gravinometers, etc. Then resistivity and seismic methods. These are really important methods when we talk about geophysics surveys. On the screen, I'm showing seismic exploration methods, but I'm going to talk about them more. We say geophysics surveys classified into two, where we have what we call reconnaissance surveys. Now, we have detailed surveys and reconnaissance surveys under geophysical surveys. And we say reconnaissance runs to define the broad areas of interest in the substrata that contain the thick sedimentary layer. Now, the thick sedimentary layers have the potential of containing the hydrocarbon trap. So under reconnaissance surveys, we are looking at the thick sedimentary layers, and when we identify them, it is an indication that there could be some hydrocarbon traps, which we can try to explore in order to get this oil. Under the detailed surveys, we talk about these are conducted to locate individual geologic structures which can be drilled. So actually, we go on, we carry out deep detailed surveys after carrying out the reconnaissance method, because in this case, we are preparing for the drilling exercise itself. So we say the gravity and magnetic surveys, these are geographical survey methods, can be done as reconnaissance type surveys, because you remember these are, I've talked about these techniques that we have many of them where I talked about the geographic and magnetic surveys. So these are done under reconnaissance, because under reconnaissance we are looking at we are trying to look for thick sedimentary layers, and these an indication that there is a potential of hydrocarbon traps. We say magnetic surveys are often done using airplanes. We say, in this case, you know, it is an expensive venture. We use airplanes flying a grid pattern over a large area using magnetometers. So that is what we can call aerial surveys. Now we run aerial surveys, or which we call aeromagnetic surveys, because we need them to define areas where sedimentary rock is thick enough to warrant further detailed studies. Now, By carrying out aerial surveys using aeroplanes, we can try to search for sedimentary layers with that has the potential of containing hydrocarbons. And I said that we search for sedimentary layers by only running what we call a reconnaissance survey. And then gravity and magnetic surveys are also frequently done from ships to find sedimentary basins in offshore areas. Umanyi tusobola oil musanga mu mazzi, mu oceans, mu nyanja, mu gayanja aganene. So in most cases, we can do reconnaissance surveys using gravity and magnetic surveys, using ships in these areas in the sea, and this will tell us that here there are sedimentary layers. And whenever we are looking for sedimentary layers that trap hydrocarbons, that is reconnaissance survey. And after doing this, then we go on to bring in the detailed survey, which will try to define the geological structure, and the geological structure will explain what we need to carry out the actual drilling. So let us stop here for now.